Hi, I'm going to do 600 Club Worksheet 1. Now again, this says, this is on the subject exponents. Everybody needs a refresher. But I picked this subject because these are the types of mistakes or weaknesses that I see students that are anywhere from the range of 500 to about a score of a 650 in math. These are questions that even a person with that good of a math score would still maybe be missing. So let's do it. Says a to the power of -1/2. Well, when an exponent is in a negative, that means we could move it from the numerator or the denominator and change the exponent sign. So that would be, can be rewritten like this. And this is another way to write that. Now we know something more about this expression, a to the -1/2. We know it equals 3. So we can do a swap here. Instead of this being here, we can move it up, and the 3 we can move down. So let's swap places here. And now this is starting to look like something we could solve. So some might think about which of these numbers would make this a true statement. You might also just use algebra and undo the square root sign to square both sides. All right, so that would look like this. And we get our answer, 1/9. Now, this is what I would consider an easier, not easy, but easier than many of the following ones. So hopefully you got that right. Another way to do it is just kind of plug these in until that would make a true statement. I'd also suggest that for this question. All right, question number 2 says, let n be the summation, or all added up, 1 squared plus 1 to the 4th plus 1 to the 6th plus 1 to the 8th plus 1 to the 10th plus 1 to the 12th, if you see the pattern. So we're adding up all the positive numbers between 0 or 1 and 50. So 1 to the power of 2 is just 1. This term is 1. This term is 1. So we're trying to ask ourselves, how many 1s do I have? And when I look at it, a couple ways to think about this, but it looks like they didn't list the odds. So half of the numbers are missing because half of the numbers are even and half the numbers are odd. So there are 25 1s there, and 1 added up by itself 25 times would be the number 25. Okay, question number 3 looks kind of similar to, what would be another question I could make it look kind of similar to, which one did I think it maybe looked like? Maybe this one, I'm not sure. I can compare 2 exponents if they have the same basis. But if they don't have the same base, it's hard to compare them. So I'm actually going to jump to number 4 and go back. So if I look at question number 4, I can rewrite this 2 to the power of x over 2 to the power of y. Well, remember this idea of negative exponents. This could be rewritten 2 to the power of x times 2 to the power of -y. Do you see what I did there? Now, when exponents are next to each other, you can actually add the exponents. Let me give you an example. So if I had 3 to the power of 2 times 3 to the power of 5, if we think about what exponent means, it's just the number of times you're going to multiply the base by itself. So this could be rewritten 3 times 3. This could be written 3 times 3 times 3 times 3 times 3. Notice how many 3s am I multiplying by itself? That's a total of 7. So as a shortcut, if it's the same base, we can merely just add. I could have just added 2 plus 5 and get 7, okay? So in the same way, I'm going to add x plus a negative y. So I can rewrite that like this. X plus a negative y looks like that. And now I can compare this left side of the equation to the right side. So when would this equal that? Well, the only way this would be a true statement is if this expression was equal to the 3. So let's set those equal and solve. So x minus y is equal to 3. Now we can answer this question. They're asking, what would x be equal to? So we must just get x by itself on one side. So we merely add y to both sides. And x is equal to 3 plus y. Okay. So x is equal to 3 plus y. So let's look at our choices. 3 plus y would be this. This is the same thing. 3 plus y is the same as y plus 3. Okay. Now let's go back to 3. Hopefully we're noticing I can't use this technique unless the bases are the same. So let's rewrite these bases. 2. This could be written as a base of 2 because that is the same as the number 4. So instead of writing the number 4, I can write this number because that's equal to the number 4. Now I have this. And you might be thinking, what do I do here? So again, if you have forgotten the exponent rules, you can go back to just writing a couple of them out to see if you add or multiply. So if we think back on this topic, 3 squared, if I wanted to take 3 squared to, let's say, the 4th power, well, what does that do? What do I do with these exponents? Well, let's go back to what this means. What's inside here, 3 squared, is the same thing as 3 times 3, okay? And I want to take that item by itself 4 times. So that's 3 times 3 times 3 times 3 times 3 times 3. So that item, what was inside, is multiplied by itself. So these are examples, okay? So I'm giving you another example. We notice 1, 2, 3, 4, 5, 6, 7, 8. There's 8 3s there. So notice this should remind you that I can multiply or distribute. So I can rewrite this and I have to distribute the 2 exponent to both terms. So this could be rewritten 2 to the power of 4n plus 6. Okay, now I have the left side of the equation written in base 2. I'm going to write this in base 2 as well. So the number 8 can be rewritten as 2 to the power of 3 because 2 times 2 times 2 is 8. We rewrite this exponent, and using the same technique, we can distribute the exponent. So 2 to the power of 3n plus 5. Now here's the key. We know this is supposed to be equal to that because these two expressions are set equal to each other. So if this is true, then as we said before, these exponent expressions must also then be equal to each other if it is true that the left side of the equation is equal to the right. Setting equal. I'm going to subtract 3 into both sides. Add 6, subtract 6 to both sides. I get -1 is equal to n. N is equal to -1. Ooh, something went wrong here. Ooh, I made a mistake. 3 times n is 3n. 3 times 5 is 15. Okay, so let's fix that. Okay, that would be 15 minus 6 is +9. Beautiful. And that's our answer. Good job, guys. All right. If 3 to the power of something is equal to 10, what is the value of 3 to the power of x minus 3? Once again, this idea of negative exponent. Let's take a look. 3 to the power of x minus 3. So we have 3 to the power of x. How can we make this look like 3 to the power of x minus 3? So what is this, right? Well, wouldn't this 3 to the power of x minus 3 be the same as 3 to the power of x times 3 to the power of negative 3? Isn't this equal to that? Also, isn't this equal to that? Do we see that? Also, isn't this equal to that? So now they're asking, what is the value of this? 3 to the power of x minus 3. Well, we notice that that is equal to this. And we've also been given a clue. We've been told 3 to the power of x happens to equal 10. So by substitution, notice I can substitute in a 10. So the value of this is 10 over 27. And that's one of my choices. Let's do the next one. If this expression is equal to 10 and that expression is equal to 8, what is the value of x to the 5th, y to the 5th? Okay, I like this one. So using algebra, x squared y cubed is equal to 10. I want, if they've asked you to solve for this, you need to get this by itself on one side. And that's what we're going to do. So I'm going to multiply. I've got 2 x's here. So I want to multiply 3 more, right? 1, 2, 3. And what I do to the left, I got to do to the right. Now I could have also just written it like this. X to the 3rd times x to the 2nd. That should be true, correct? So I'm getting closer. I've got x to the 5th, y to the 3rd, 10x to the 3rd. Now it's not quite. I need to get y to the 5th by itself on one side. Okay, so I need 2 more y's here. So 2 more y's, and what you do to the left, you must do to the right. That's algebra. So now here on the left, I have x to the 5th, y to the 5th, and we want to know what it is equal to. That's what we've been asked. So on this side of the equation, I have 10x to the 3rd, y to the 2nd. Well, this is very convenient. And a lot of times this happens on SAT. They gave you x to the 3rd, y to the 2nd, also happens to equal the number 8. So this stuff also happens to equal the number 8. So I'm just going to use substitution. And I get x to the 5th, y to the 5th is equal to 80. I'm going to try to go to the next video. All right, check out the next one. See you in a sec.